I wanted to conclude this video with a few examples of some of the problems on the worksheet that you have gotten from Dr. Dolo. And I was going to use the improper integration worksheet that he passed out because he hasn't really gone over it many of these problems, and I also find these problems to be a little bit more challenging. So I'm going to start with question D. And it asks for you to evaluate the integral from negative infinity to 0 of 5e to the 2x dx. So you know the first step to an improper integration problem is to change your improper bounds. You have one improper bound in this problem, which is negative infinity down here. So we're going to write the limit as a approaches negative infinity of the integral from a to 0 of 5e to 2x dx. And then after this, you can just integrate as you would, and then worry about the infinity sign later when you plug it in. So from here, you could pull this 5 out. Remember to keep on writing this limit as a approaches negative infinity until you plug infinity in for a. Five a to 0 e to 2x dx. Now this is a doable integration problem. It is a use substitution problem because this x has a 2 in front of it. So off to the side, I'll write let u equal 2x. And then we have to find the derivative of u. So du over dx equals 2. And then we have to solve this problem, solve dx in terms of du, so we can plug back into this function. So du equals, because you multiply dx, those will cancel out, and then multiply dx over here, so 2 dx, and then you divide this 2, dx equals du over 2, which you can also write as 1/2 times du. And this is another constant which we can also take out of the integration function. So I'm just going to do that right now. I'm going to bring down my limit as a approaches negative infinity of 5 over 2. Got the over 2 from this 1/2 that I pulled out and multiplied the 5 of the integral from a to 0 of e to the u du. Now we all know that the derivative of e to the u is e to the u. So the antiderivative, or the integral of e to the u, is also e to the u. So we can get rid of the integral sign because we've integrated. Keep on writing the limit though, because you haven't plugged in the negative infinity yet. 5 over 2 e to the u evaluated from a to 0. And you could go ahead and plug the 2x for u back in, and go ahead and plug the infinity back in. So 5 over 2 e to 2x evaluated from negative infinity to 0. Now all you have to do is do the top minus bottom like you would always. So 5 over 2 times e to the 2 times 0 minus e to the 2 times negative infinity. Now, e to the negative 2 infinity, or that'll just be e to the negative infinity, can also be written as e to the negative infinity can be written as 1 over e to the positive infinity, since it's the negative exponent. You can bring it down to the denominator, and this number will forever and ever get bigger and bigger and bigger. So this number will equal 0. So this e, since it goes down to the denominator, this is 0. And you know any number raised to the 0 power is 1. So this will be 5 over 2 times 1 minus 0. So the answer will be 5 over 2.